let's get into today's video about the product rule. So we're going to continue the derivatives portion of our series. So we learn a whole bunch of rules about doing derivatives, but today we're going to learn the product rule. So let's say p of x is equal to f of x times g of x. Now these two are multiplying by each other. So when I want the derivative p prime of x, the derivative is going to be this rule. You take the derivative of the first function, f prime of x, and you multiply it by simply the second function, g of x. Then you add f of x times the derivative of the second function, g prime of x. So, if you want to write it in the Leibniz format, you can do if u and v are functions of x, dx of u times v is equal to the derivative of u with respect to x times v plus u times the derivative of v with respect to x. So let's actually put that into an example. Let's say we have so what we can do is say that this is f of x and this is g of x. So, but let's just quickly find the derivatives of each of these. So, if f of x is equal to x squared plus 5, f prime of x is equal to the 2 comes down, and I'm left with 2x. The constant becomes 0. G of x is equal to x plus 5, but g prime of x is just, that's 0, and then the x becomes 1. So if I wanted to rewrite it in the formula p prime of x, f prime of x times g of x plus f of x times g prime of x. So f prime of x is equal to 2x. G of x is equal to x plus 5 plus f of x, which is x squared plus 5 times g prime of x, which is 1. And when you simplify that, you should get let's say 2x squared plus 10x plus x squared plus missing something? Nope, I think that's it. So let's move on to a different example, or I can actually show you why this works, because if you just did it from, say, the x squared plus 5, if you were to expand this, you would have x squared times x cubed plus 5x squared, and then you would have had 5 times x plus 5x plus 25, so this would be x cubed plus actually wait, that's it. So your p of x would be this if you expanded that, and if you were to do the derivative of that entire polynomial, you would have had 3x squared, because the 3 comes down and you subtract 1 from the exponent, and then you have 2 times the 5, which is 10, and the x gets exponent of 1, and then you have the 5x, and this would become 0. So that is equal to that. I forgot that 5 over there. Anyways, let's try another one. Let's do h of x is equal to x squared minus 3x times x to the 5 plus 2. Now let's say the first one, f of x is equal to x squared minus 3x, but f prime of x equal to 2x minus 3, because x squared becomes 2x and negative 3x becomes negative 3, and my g of x is going to be x to the power 5 plus 2, so g prime of x is going to be, the 5 comes down, 5x to the 4, and the 2 is a constant, so it's gone. So if I was to write this out, h prime of x is going to be f of x, which is x squared minus 3x times the derivative of g of x, 5x to the 4 plus f of x. Okay, I may have written this backwards. Let me just move that over. So I should actually write my f prime of x first, right? Because I want my f prime and then my gx, which is x to the 5 plus 2, and then I have my f of x, which is x squared plus x squared minus 3x, and then I have my g prime, which is that. So now if I simplify this, I will get let's start opening it up. 2x to the 6 minus 3x to the 5 plus 4x minus 6 5x cubed plus 7x squared plus 3 times 2x squared plus x plus 6. And now I want to find h prime of x at -1. That's what I want to find. So let's write out our, say this is our f of x. Is equal to 5x cubed plus 7x squared plus 3. Our f prime of x is equal to 15x squared plus 14x, and our g of x is equal to x squared plus x plus 6. Our g prime of x is equal to 4x. Yeah, well, 4x. And then our x becomes 1, our constant is gone. So, if we were to write it out using our product rule, first we would write our f prime 15x squared plus 14x. Oh, that's a big gap there. Plus 14x times our g of x, 2x squared plus x plus 6. Now our second portion, we're going to write our f of x, 5x cubed plus 7x squared plus 3 times our g prime of x, 4x plus 1. And now, instead of simplifying, expanding and simplifying, all I'm going to do is just plug in -1. So I should have 15 -1 squared plus 14 -1 2 to the -1 squared plus -1 plus 6 plus 5 -1 cubed plus 7 -1 squared plus 3 times 4 -1 plus 1. So if we evaluate this, that'll become a positive 15. And that'll become -14, so that'll be a 1. This one will be 2 minus 1, which is 1, plus 6, 7. And then I have here, this will stay -1, so that'll be -5 plus 7, which is 2 plus 3, 5. Here I have -4 plus 1, which is -3. So I have 7 minus 15, which is going to be -8. And that's how easy it is to use the product rule. So let's do one more thing. This is called the similar or like related power of a function. this basically is going to cover you if you have a, say, f of x equals to x plus 1 with a power, like, and you want to do the derivative here. So the rule of thumb here is that if you have f of x, well, say x is a function of f, then you'll have d over dx. Actually, let me use a better example here. Let's say I have a function u, and u is a function of x, and n is an integer. So let's say u to the power of n, and u is a function of x, and let's say you want to do the derivative with respect to x. So the derivative of u to the power of n is actually n times u to the power of n minus 1 times the derivative of the function u with respect to x. So we can actually try that here. Say we have x, h of x is equal to x squared plus 3x plus 5 all to the power of 6. So h prime of x is going to be, let's just put that in here, 6 times the same function u, x squared plus 3x plus 5 to the power of n minus 1. So n was 6 now. It is going to be 5 times the derivative of u, which is going to be 2x plus 3. And that's how easy it is. These are just rules that'll make our lives easier. Let's do this one. Say f of x is equal to 2x plus 5 divided by 3x minus 1. So this can actually be rewritten as 2x plus 5 times 3x minus 1 to the power of negative 1. And this is where it's going to get really big. So let's actually, I'm gonna call this p of x, and then I'm gonna write this out. F of x is equal to 2x plus 5. F prime of x equal to basically x. Sorry, no. The derivative of 2x is 2. Okay. And then our g of x, which is the second term, is 3x minus 1 to the power of negative 1. But our g prime of x this can go to the denominator. And then here I have the 3 and the negative 1, so that'll be negative 3. Actually, I forgot this exponent right here. That has a minus 1. So I have a negative 3, and in the numerator I have this 2x plus 5, and the denominator I'll bring down this 3x minus 1 squared. And if I multiply this side by 3x minus 1 over 3x minus 1, so and then I'll expand the numerator there. I'll multiply the 3, and so 6x plus 15 over 3x minus 1 squared. And so the numerator will become 2 times 3x, which is 6x, and then that'll be minus 2. Here I'll have 3x minus 1 subtract 6x plus 15 over 3x minus 1. Sorry, forgot the square. So simplifying all that, 6x minus 2 minus 6x minus 15, that'll give me 3x minus 1 squared in the denominator. And I should be left with 6x minus 6x. So I have negative 2 minus 15, so that's negative 17 in the numerator, and I have 3x minus 1 in the denominator. And that's that. And if you want to try it on your own, you can try using the product rule to do this 3x plus 2. A little homework for you, 2x plus, and find the derivative, h prime of x. And if you want to use both that product rule and the power rule, you can try h of x is equal to x squared minus 9 to the power of 4 times 2x minus 1